Good morning, grade 9. How are you doing? I hope you are fine. Today we're going to continue the second part of the lesson that we have started on Thursday. The lesson is radical expressions and rational exponents. It is lesson chapter 5, lesson 6. Okay, girls, let me remind you and make a quick review about the cases that we will find when we have real roots. If I have an odd index and a positive radicand or a negative radicand, odd index for all cases, I will get one real root. Even index and positive radicand, I will get two real roots. Even index and negative radicand, 0 real roots. Radicand of 0 is 1 root of 0. Okay, girls, and we solved some problems for this case, and we were going to continue properties of the nth roots. Okay, product property of roots. The nth root of a product is equal to the product of the nth roots. Nth root of a product is equal to the product of the nth roots, like cubic root of 16 is equal to cubic root of 8 multiplied by cubic root of 2. Why? Because when I multiply 2 and 8 together, they will give me 16. So I will say which two factors, when I multiply them, they will give me a product of 16. But one of them can be easily get its answer. So it is 8. So cubic root of 8 is 2. And I will keep cubic root of 2 as it is. So when I factor 16, let me say factor 16 into 2 factors, I will choose that one of them will be an easy cubic root to be solved, like 8, like a perfect cubic root. So 8 multiplied by 2 is 16. So cubic root of 8 is 2. So now I have finished this part and it is equal to 2. Then the final answer is 2 multiplied by cubic root of 2. Quotient property of roots. The nth root of a quotient is equal to the quotient of the nth roots. Like root of 25 over 16 is root of 25 over root of 16. I will distribute the roots upon 25 and upon 16. I will distribute the root upon 25 and upon 16. So square root of 25 is 5, square root of 16 is 4. So it can be written in this form. The nth root of a over b is equal to nth root of a over nth root of b. Let's take an example that will make everything more clear. Simplify each expression. Assume that all variables are positive. Okay, like cubic root of 27 multiplied by x to the power 6. 27, I will say to myself, 27 is which number that I will multiply by itself 3 times and it will give me 27. It is 3. So I can make 27, I can change it to 3 to the power 3. I can change 27 to 3 to the power 3. And I can change x to the power 6 to x to the power 3 and x to the power 3. Because when I multiply two exponents, I add them. So 3 plus 3 is 6. So now factor into perfect cubes. Factor into perfect cubes. and easy cubes and easy roots to be solved. So 27, when I factor it to perfect cubes, it is 3 to the power 3, 3 cubed. And x to the power 6, I factored it into x to the power 3 and x to the power 3, x cubed and x cubed. So now I can distribute the cubic root upon the 3 terms. I can distribute the cubic root upon the 3 terms. So it will be cubic root of 3 cubed multiplied by cubic root of x cubed multiplied by cubic root of x cubed. Cubic root of 3 cubed is 3. Cubic root of x cubed is x. Cubic root of x cubed is x. So my final answer is, when I simplify it, is 3x squared. Let's take another one. Cubic root of x cubed over 7. So I can distribute them, the cubic root, on x cubed and on 7. So it will be cubic root of x cubed over cubic root of 7. Cubic root of x cubed is x, and the denominator will remain cubic root of 7. Simplify the numerator. Then rationalize the denominator. Rationalize the denominator. Because it's better to not keep a root in the denominator. It is better to do not keep a root in the denominator. So how I will get rid of this cubic root? How I will get rid of this cubic root? I will rationalize the denominator. I will rationalize the denominator. How I'm going to rationalize the denominator? It is cubic root, right? So I will multiply by cubic root over cubic root and cubic root over cubic root of 7, of course, all of them. Why? Because this one, cubic root of 7 over cubic root of 7, it will give me 1, as if I didn't write it, right? Here comes, yes, it will give me 1. And when I cancel them, it will give me 1. And this one will remain the same as the original answer, this one. So I want to rationalize it. Rationalize it means do not keep any root in the denominator. It is cubic root, so I'm going to multiply by cubic root numerator and denominator, and another time cubic root denominator and numerator and denominator. So now I have 3 cubic roots. 3 cubic roots. So cubic root of 7 multiplied by cubic root of 7 multiplied by cubic root of 7 is 7. If I go up here, cubic root of 7 multiplied by cubic root of 7 multiplied by cubic root of 7, it will give me here 7. Okay, because it is cubic root of 7 cubed. Cubic root of 7 multiplied by cubic root of 7 multiplied by cubic root of 7, it is cubic root of 7 cubed, which is 7. So now I rationalize the denominator. No more cubic roots or no more roots in the denominator. What about the numerators? I have cubic root of 7 multiplied by cubic root of 7. So it is cubic root of 7 squared. So it is cubic root of 49. Again, what if I have this one square root, not cubic root? If I have square root, not cubic root, what I am going to do? I will only multiply it by square root of 7 and square root of 7. So in all, I will have 2 roots. But since I have cubic roots, so I must have 3 roots. If I have square roots, so I must have 2 roots. If I have cubic roots, I must have 3 roots. If I have nth root, for example, 4, so I must have 4 roots. I multiply, so the final number of roots will be 3. Up and down, up and down. Okay, girls, Let's watch this one together.
Let's see how we can simplify different roots. Now, just for the sake of argument, we're going to assume that all the unknowns, all the variables that we see are all going to be positive, so we don't have to worry about whether the roots really exist or not. So everything is positive. All right, here we go. Let's simplify this. We're taking the fourth root of 16 times x to the 12th. How to think about this? Well, the first thing I'm going to do is I'm going to realize that I can use the properties that I know about roots. First one is I can break this up into the fourth root of 16 times the fourth root of x to the 12th. Now, x to the 12th is actually x to the 4th times x to the 4th times x to the 4th. Why? Because if we are multiplying the numbers and they have the same base, we just add the exponents. 4 plus 4 plus 4 is 12. And now, well, the fourth root of 16, that's actually easy. That's just 2, because 2 times 2 times 2 times 2 is 16. So that's okay. And here I'll use the property of roots again to rewrite this as the fourth root of x to the 4th, fourth root of x to the 4th, fourth root of x to the 4th. Well, what's the fourth root of x to the 4th? Well, that's just x, right? Because x raised to the 4th power equals the thing that's inside the fourth root. So then I have x times x times x, and so that equals 2 times x cubed. So I could simplify this complicated expression to one that just looks like 2 times x cubed. Neat. Let's try the one. Here we go. Let's simplify this. Well, the first property of roots that I can use is that I can write this as taking the root of the numerator, the third root in this case, of the numerator, and divide that by the third root of the denominator. Well, here I'm taking the third root of w cubed, and so that's just w. Why? Because w cubed is w cubed, so that is exactly what I want. Divided by the cube root of 5. Now, from my point of view, that's simple. That's the way I would leave it. But some people actually like you to rationalize the denominator, make that an actual rational number rather than some kind of complicated number like this with a root. So if you want it, so this is a good answer, but if you want to simplify the denominator a little bit, you could actually multiply by the cube root of 5, cube root of 5. Now, if I do that on the denominator, I best do that in the numerator, otherwise I'm going to change the value, and I won't be allowed to write that equal sign. And now I can use the properties of roots again to write this as just one root, the root of 5 times 5, which is 25. And then here, what do I have? Here I have the root, the third root of 5 times 5 times 5, which is 5 cubed. The cube root of 5 cubed is just 5. It's exactly what I wanted. I wanted to have a nice whole number down there, and you can see that I've got a nice whole number down there. So I'd say either this solution is a nice simplified version, or equivalently, this solution where the denominator now is a whole number. Either way is fine, just depending upon what the question asks. But you can see that we can simplify things using some basic properties of roots. Cool.
Okay, girls. Let's go back to our book. Okay, we have another part that we're going to study. A rational exponent is an exponent that can be expressed as m over n, where m and n are integers and n is not equal to 0. Radical expressions can be written using rational exponents. Okay, for any natural number n and integer m, I can have this one. The exponent 1 over n indicates the nth root, like 16 to the power 1 over 4 is equal to square root of, 16 to the fourth root, which is equal to 2. So a to the exponent 1 over n is equal to a to the nth root. A number, its exponent is a fraction, 1 over n. It can be written as this number and its nth root. The denominator is the index. Okay, girls, the denominator is the index. Put it in your mind, you can study it like this. The denominator is the index. Okay, the exponent m over n indicates the nth root raised to the mth power. So 8 to the power 2 over 3 means that, as we said, that the denominator is the index, so it is 8 cubic root of 8, all of this term to the power of 2, all of this term squared. So when I want to distribute here the exponents as denominator and numerator, okay, 2 here will be distributed here for the whole term, and 3 here, the denominator will be the index. The denominator will be the index, and 2 will be an exponent to the whole term. So cubic root of 8 is 2, and all to the power 2. So cubic root of 2 is 2, all to the power 2, 2 to the power 2 is 2. So it is 4. So let's read the rule. A m over n is equal to root a to the nth root all multiplied to m. Okay, girls. So let's go to the second page to solve more examples for this rule. Okay, writing expressions in radical form. Write the expression negative 125 to the power 2 over 3 in radical form. How I am going to write it in radical form? Follow the steps. Write with a radical. So the denominator will be the index. So this number, I will put for it a radical sign, and its index is 3. All to the power of 2. So negative 25 cubed is negative 5, referring to the first rules that we have studied in this lesson. All to the power 2, so negative 5 to the power 2 is 25. Another one here. Evaluate the power first. We have another method here. Evaluate the power first. Like, I'm going to write 2 for as an exponent for the radicand here. Here in this one, all the term has the exponent of 2. But in this method, the radicand is raised to the power of 2. So negative 125 squared is 15,625, so its cubic root is 25. I prefer that you use method 1. Okay, girls? So if you're going to answer this one, 3a, okay, Here I have 64, the radicand, and the index is the numerator. The index is the denominator. So the denominator here is 3. So the index here will be 3. So 64 cubic root of 64. So the cubic root of 64 is 4, because 4, when I multiply it 3 times, it will give me 64. Okay, let's solve the second one. 3b. Okay. The denominator is the index. Okay. And all to the power of 5. Because the numerator will be the exponent for the whole term. And inside I have the radicand, which is 4. So square root of 4 is 2. 2 to the power 5 is 32. What happened here? I distributed the numerator and the denominator here. 2 here, the denominator is the index for the radicand 4, and 5 is the exponent for the whole term. So the square root of 4 is 2. 2 to the power 5 is 32. Let's do the last one here. Okay, so the denominator is 4, so the index will be 4, and all of the term to the power 3, and the radicand is 625. Which number, when I multiply it by itself 4 times, it will be 625. What about the 5? When I multiply it 4 times by itself, it will be 625. So it is equal to 5 to the power of 3, which is equal to 125. Okay, girls, here we have the opposite. Write each expression by using rational exponents. I am going to do the opposite. Okay, here the index is 4, so the denominator will be 4. And here, this time they use the second method, which they give the numerator to the exponent of the radicand. So it is 3. Okay, here I have the same. 11 is the radicand, so I will write 11. And the denominator is the index is 3, and 6, I will write it as the numerator. And 6 over 3 is 2, so I can simplify it as 11 to the power 2 is equal to 120. If I will solve for A here, I'm going to write 81 to the power, the index is 4, so the denominator is 4, and the numerator is 3. Here I have 10. The index is 3, so the denominator is 3, and the numerator is 9. 9 over 3 is 3. So 10 to the power 3 is equal to 1000. For C here, 5. The index is 4, so the denominator will be 4. And the numerator is 2. When I simplify it, it will be 1 over 2. So it is 5 to the power 1 over 2. Okay, properties of rational exponents. Product of powers property. To multiply powers with the same base, add the exponents. If I have the same base, so I can add the exponent. To multiply powers with the same base, add the exponent. So I have 12 to the power half multiplied by 12 to the power 3 over 2. I'm multiplying the same base, so I'm going to add the exponent. So it is 12 1 half plus 3 half, so it is 12 3 over 2. 4 over 2. It is 12 to the power 4 over 2 to the power 4 over 2, which is 2. 12 to the power 2 is 144. Let me write it for you here. Half plus 3 over 2, it will be, I will keep the denominator as it is, 1 plus 3 is 4. When I simplify it, it is equal to 2, which is this exponent. Okay, quotient of powers property. To divide powers with the same base, subtract the exponents. I have the same bases here, dividing to each other, so by each other. So I will write 125 and I will subtract the two exponents. I'm going to subtract the two exponents. 2/3 minus 1/3, so it is 125 all to the power 1/3. 125 to the power 1/3, it can be written in this form, 125. The denominator is 3, so the index is 3, so it is cubic root of 5, which 125, which is 5. Okay. Power of a power property. To raise one power to another, multiply the exponents, like 8 to the power 2/3 all to the power 3. So I'm going to multiply 2/3 by 3. 2/3 multiplied by 3 is 8 to the power 2, because 3 is going to cancel the 3 here, so 2 will remain. So it's 8 to the power 2 is equal to 64. Power of a product property. To find the power of a product, distribute the exponent, like 16 multiplied by 25, so to the power half. I'm going to distribute the exponent here, and I'm going to distribute the exponent here. So it will be 16 to the power half multiplied by 25 to the power half. So it will be 4 multiplied by 5, which is 20, because this one is the square root of 16, which is 4, and this one is the square root of 25, which is 2, which is 5. Okay, power of quotient property. To find the power of a quotient, distribute the exponent. So 16 over 21, 81 to the power 1/4, so it will be 16. 1/4 will be distributed here, and 1/4 will be distributed here, so it will be 16 to the power 1/4 over 81 to the power 1/4. So it will be 2 over 3. Okay, let's go to the second page to see more examples. Okay. Next page, example 5, simplify each expression. So I have the same basis here, and I have multiplication sign here. So if I have the same basis and multiply, so I will add the exponents together. So 25 to the power 3 fifth plus 2 fifth. So it is 25 to the power 5 fifth, which is 25 to the power 1, which is 25. B. I have here dividing the same bases together, so I will subtract the exponents. So 1/3 minus 2/3, it is negative 1/3, which means 1 over 8 to the power 1/3, which is 1 over 2. And you will tell me how 8 1/3 is equal to 2. I will tell you the same. I have here 8 as a radicand and 3, the denominator is the index. So cubic root of 8 is 2. Okay. Here I have 36 to the power 3 over 8 multiplied by 36 to the power 1 over 8. So it will be here 36 to the exponent 3 over 8. Let me write it like this, 36, because it's hard to write the exponents here. And I will write above it here another text here, to the power 3 over 8 plus 1 over 8, which is equal to 4 over 8, which is equal to 1 over 2. 36 to the power 1 over 2 means 36. And the index is like the denominator, so it's equal to 6. Okay, girls. (5b) negative 8 to the power negative half, negative 1/3. So I am going to distribute the power here, negative 8 to the power of negative 1/3 to the power of negative 8. Negative 8 has a power of 1, so it will be negative 8 to the power negative 1/3. It will remain the same. So it will be negative 1 over 8 to the power 3. I will write it like this. Negative 1 over 8 to the power 1 over 3. I'm facing some problems in writing exponents here. That's why I'm taking a long time to answer each one. So 1 over 8, negative 1 over 8 to the exponent 1/3. 8 to the exponent 1/3 is equal to 2. So my answer is equal to negative 1 over 2. Okay, 5c, I have here dividing the same basis. So I'm going to write 5 to the exponent 9 over 4 minus 1 over 4 because I will subtract the exponent. So it's equal to 5. 9 minus 1 is 8 over 4. When I simplify the power, it will be 5 to the power of 2, which is equal to 25. Okay, girls, let's watch here videos to get the idea. I will let you watch a video for example 4. First, for example 5.
All right, let's see how we can combine numbers that actually have rational exponents. Let's start out with a multiplication question. So here I have 8 to the 3/4. I'm going to multiply that by 8 to the 5/4. What do we get? Well, there are lots of rules about powers, and I want to remind you of them. You've seen these before, and it turns out that all these apply even when the exponents are rational numbers. First of all, if you take the product of powers, you just add the exponents. So a to the m times a to the n equals a to the m plus n. Quotient of powers, we take the difference of the exponent of the numerator minus the exponent on the denominator, so a to the mn in this case. A power of power, a to the m, all raised to the n, we multiply those exponents. A power of a product, ab to the m, we can take a to the m and multiply it by b to the m. And a power of a quotient, we can again, a over b to the m is just a to the m over b to the m. All those rules, all of them, go over even if the exponents are rational. So here, since the base is the same, I can add the exponents. So I see it's 8 to the 3/4 plus 5/4, which equals 8 to the 8/4. Well, 8/4 is the same thing as 2, so this is actually 8 to the 2, or 8 squared, which actually I happen to know is 64. So look at that really complicated looking thing, which, by the way, each number individually would be hard to compute exactly. However, once you take the product of those two complicated numbers, we see a simple 64. Kind of interesting. In math, we see that a lot. Sometimes a really complicated something multiplied by another complicated something, the complexity sort of fits together perfectly, and all of a sudden the answer becomes simple. There's a great example of that. Let's try another one, which I just dropped, sorry. Here we go. 125 to the 1/3 divided by 125 to the 2/3. What do we do here? Well, here, since we have the same base, we can write that common base. And since we're looking at a quotient, we can subtract the exponent. So I have 1/3 minus 2/3, which equals 125 to the negative 1/3. What does a negative exponent mean? Well, that, remember, means that we take a reciprocal. So 1 over 125 to the 1/3. Boy, there's so many ways to make mistakes here. I can't even list them all. For example, here's a great mistake. You might say, okay, I'm going to take a reciprocal, and then you actually take a reciprocal of the exponent as well, and you write 125 to the 3rd power. That would be a great mistake. To lop off that negative sign, what you've got to do is take a reciprocal of the whole thing, but that exponent stays intact, because that means take a root. So this equals 1 over the 3rd root of 125, which I happen to know is 5. 5 times 5 is 25, times 5 is 125. So this actually is 1 over 5, or 1/5. So again, we see the same kind of example, although it was a little bit more elaborate. Very complicated number to compute, very complicated number to compute, and yet when you take the quotient of those two numbers, it turns out it just equals 1/5. Absolutely cool. Pretty cool.
Okay,
All right, let's see.
Okay, girls, I hope you got the point and you understand. I know that this lesson has many rules, but we have to study them all and to practice more and solve more problems. So feel free if you want to ask me any question, and don't forget to answer your homework. Thank you so much.